So gases in chemical reactions. Most of the time when we have gases as part of a chemical equation or a chemical reaction, the amount of gas is given in volume. Instead of having grams of this substance, if that substance is a gas, the amount of that gas is given in volume, like in units of volume. So we can actually solve problems using stoichiometry for chemical reactions involving gases. And there's not just one way of doing this, but in general, what you have in your problem, it's enough information for you to find moles of something, moles of one of the gases in your actual chemical equation. And then using that number of moles, we can find moles of something else using stoichiometry. And depending on what the problem is asking you to find, you can use that number of moles and you can get grams, or you can use that new number of moles and you can find a volume or a pressure or something different in your problem. So whenever you have a problem for gases, the best thing to do is to identify the information that you have and think about what you can calculate with the given information. So I have a problem here, and whenever you have a problem including the chemical equation, it's because you have to use the molar ratios from your equation to find something, to find a number of moles for a specific substance in your chemical equation. So I have here information, I have a volume, and I'm underline everything, volume of H2. I have a temperature and I have a pressure. A temperature in kelvins, a pressure in atmospheres, and I have a volume in liters. Now, that temperature and pressure that is in your problem, it's temperature and pressure for all of this. So all of your chemical reaction, it's happening in the same container. And you have the temperature and you have the pressure. Now, if you look at your equation for the ideal gas law, your equation is PV and RT. Checking your numbers here, look, you have a value for temperature, you have a value for pressure, you have a value for volume. That's all you have. Your constant, it's always the same number, 0.082 liters times atmosphere over mole times Kelvin. So looking at your equation and the information that you have, the only thing that you're missing in your equation is N. N is the number of moles. Now, important thing, this is asking you to find out the moles of NH3. And you might be thinking that since you have everything besides moles, that you can use all of these numbers to find out the moles that you need to calculate. But that is not correct, because the moles that you want to calculate are moles for NH3. And the volume that you have, it's volume for hydrogen. Your volume for hydrogen, you can use that volume to find out moles for hydrogen, because the volume of hydrogen is due to the moles of hydrogen in your container. So you cannot use your information here to find moles of NH3. Okay. That is not correct. You can only use your numbers to find moles of H2 because the volume is for hydrogen. So you can calculate the number of moles of hydrogen at that temperature, that pressure, and when the volume of your container is 2.5 liters. So I'm going to go ahead and get N, and N, you're solving for N here, so you need to divide both sides by R times T to cancel out RT from here, and then that will give you PV over RT. Your pressure is 1.82 atm. Your volume is 2.5 liters for hydrogen, and you're getting moles of hydrogen. Your constant, and I'm writing down the units, all of them, kelvins, mole times Kelvin, and the temperature is 381 kelvins. So you can check the units that are canceling out, atm with atm, liters with liters. You have your kelvins canceling out with kelvins, and the only unit that is not canceling out will be unit of mole, which is what you're trying to calculate. Okay? So to get my number, 1.32 times 2.5, that divided by 0.082. Number of moles for hydrogen, H2, I have 0.1056, so I'm rounding to 3 significant figures, and that will be 0.106, and that is the moles for H2. Remember, moles of H2, because the given volume is H2, so you cannot use the volume for H2 to find out moles of NH3 plugging in your numbers in the equation. So usually you're using your PV equals nRT to calculate N, and then you have to use stoichiometry or the molar ratios to find out your final answer. You need to get the moles of NH3. So what you have, it's your moles of H2 and we need the molar ratio from your equation. For every 3 moles of hydrogen that are reacting with your nitrogen, you're getting 2 moles of NH3. So you're trying to get moles of NH3, which means that that number goes on the top part of your conversion factor, 2 moles for NH3 over 3 moles for H2. 3 moles of H2 is this one right here. 2 moles of NH3 is this one right there. NH3, the one that you're trying to get. H2, the one that you're trying to cancel out. Moles of H2 cancel out with moles of H2, and what you are going to be getting from this calculation is the moles of NH3. And the moles of NH3 is what you're actually trying to calculate. So 0.106 times 2 divided by 3. Something close to 0.07. Okay? That's the number of moles of NH3. So when you have 2.5 liters of hydrogen at those conditions for temperature and pressure, this is the number of moles of hydrogen that you have. Okay? So if this many moles of hydrogen are reacting, what you're forming is this many moles of NH3. That's what you were trying to calculate in this problem. So I have another problem right here, and this one is a little bit more complicated, not by that much. I'm going to show you what you have, and I'm going to write down the final answer, just the final answer. You have a volume for chlorine gas. Okay. You have a pressure and you have a temperature. Chlorine gas is one of your two reactants. So the problem is telling you, okay, this is how much chlorine gas you have. You have an excess of potassium, which means that that's not your limiting reactant. So the amount of product that you're getting here will be due to the amount of your chlorine gas. Okay? So you have a pressure, you have a temperature, and you have a volume. So you can actually calculate the number of moles, because from this equation, you have your pressure, you have the volume, you have the temperature, and you know that number, so you can get N. The N that you can calculate right there, it's N for chlorine gas, which is Cl2. But that's not what you're trying to calculate, right? That's not your final answer. That's what you can calculate with the given information. That's it. What you're trying to get is mass of potassium chloride. Okay? So with the information that you have, you can calculate the moles of Cl2. You can convert moles of Cl2 to moles of KCl, and to go from moles of Cl2 to moles of KCl, which is your potassium chloride here, you need to use stoichiometry. Every 2 moles, to get 2 moles of potassium chloride, you need 1 mole of your chlorine gas. Okay? So your factor, your conversion factor will be 2 moles of KCl over 1 mole of Cl2. Once you have the moles of KCl, you can convert that to grams of KCl using the molar mass of KCl. So I'm going to do the calculation and I'm going to write down the final answer. I'm not going to show you how to work the problem. You should try to do the problem on your own. .9 grams of KCl. Something close to 31 grams of KCl should be the answer for this problem.